Hi everyone, my name is Gabriela Cornejo and these are my findings for our Lab Report 1 on charge tape. The purpose of this lab was to determine an approximation of the excess charge left on a charged piece of tape and to reinforce the ideas of charge and matter learned in the lectures using everyday items for a better visual frame of reference. During this lab, the charge on the tape was calculated to be negative with an excess of electrons. These values were calculated using derivations of Coulomb's law and knowledge on particle charges and their properties. My expectations for this lab were that when creating two U-tapes in the same fashion, the two U-tapes would repel one another. My observations confirmed this and also provided further information on the charge of the U-tapes, such as the U-tape attracted neutral objects and repelled the negatively charged pen. Thus, I concluded that the charge on the U-tapes must be negative with an excess of electrons. In order to make one U-tape float above the other, the force of one U-tape on the other must be the only force acting in the y direction besides gravity. The image to the right demonstrates these two forces acting on the upper or floating tape, where downwards is gravitational force and upwards is the electric force in the free body diagram. The measurements I calculated during this lab are shown here. Based on these measurements, I calculated that the gravitational force acting on the upper tape was -2 times 10 to the -3 newtons, and that the electric force, which had to be equal and opposite to the gravity, was +2 times 10 to the -3 newtons. Before completing the calculations for the next part of the lab, some assumptions had to be made, such as the tape can be treated as a point charge and that the length of the tape rather than the surface area can be used to calculate the number of atoms for the sake of this approximation. To calculate the charge of the U-tapes, I used a derivation of Coulomb's law and got that the charge is equal to -6.13 times 10 to the -9 coulombs. Based on this, I found the number of excess electrons to be 3.83 times 10 to the 10. And using the tape length, I could find the number of atoms, which was approximately 2.04 times 10 to the 9th. Thus, the ratio of electrons to atoms was approximately 19 electrons for every one atom. The next part of the lab was to create a computational model of the forces acting on the upper tape using Python. I did so by first putting in my constants and measurements into the coding software. I then did my calculations for gravitational force, the charge, and the electric field, while also adding in the setup for my two particles. I then found the electric force using the calculated charge and electric field and included the number of electrons, the number of atoms, and the ratio to make sure that I had all of my calculations in the model. This portion of the code shows how I modeled the forces using arrows and where I defined my function for finding electric field. The part that says print a bunch of times is just how I showed my calculations with my model. These two images demonstrate what happens when I run my code. The numbers on the left are the calculations that the computational model did, and the image on the right is the model of my two particles, the upper and lower tape, with the upper tape having the force of gravity pointing down in the pink arrow and the electric force pointing up with the green arrow. The computational model calculated the magnitude of the charge to be -6.13016 times 10 to the -9 newtons. In order to make these calculations, I had to make a few assumptions, such as treating the U-tape as a point charge with the charge concentrated at the center, assuming that both tapes have the same evenly distributed charge, and ignoring outside factors such as air resistance and making sure that the only two forces were the force of gravity and the electric force. My answers to the final questions posed at the end of the lab are as follows. If electrons had a positive charge, then the observations I made would be opposite, which means that the tape would now attract the negatively charged pen rather than repel it. The only thing that would stay the same is that the U-tapes would still repel one another. For the question on why it's important to handle the charged tape as little as possible, I said it's because contact allows for a transfer of charges to occur. When the charged tape comes into contact with some neutral object, like your hand, the electrons from the tape will be transferred to the more neutral object, thus changing the charge of the tape. In conclusion, the results of this lab proved the charge of the U-tapes to be approximately -6.13 times 10 to the -9 coulombs, meaning that the U-tapes had excess electrons. The ratio of electrons to atoms was also approximately 19 to 1. Thus, the observations and expectations stated at the start of this lab report proved to be accurate.